Okay, this is the solution to problem 2 from the exam that Kuklin gave you guys as a practice exam. Um, this is basically just manipulating chapter 4 equations. So in this problem, you're given a copper wire that's 10 meters long. So we have length here. The wire has a diameter of 5 millimeters. So if we have diameter is 5 millimeters, we also have radius is equal to 5 millimeters over 2, right? Electron density of 10 to the 23 centimeters to the negative 3. So our electron density is going to be, I forget it's equal to n. That's the variable for that one. And then conductivity, so that's sigma. So basically, this is like a quiz of do you know what all of these things are called, basically. So drift velocity, VE, of the electrons, and then power dissipating, so P for power. And then we have our voltage is equal to 50 volts. Okay, so to be able to use this, we're going to need to manipulate a lot of chapter 4 equations. So I put some of them here. Obviously, this is not extensive. I would definitely go back and look at kind of the stuff from chapter 4. This is all algebra. So the math itself isn't complicated, but the concepts, there's a lot of moving parts here. Okay, so we have conductivity. So we're trying to find drift velocity and power dissipating. So this is our drift velocity. Okay, and so we have our value for our E fields because we can do voltage divided by our length here. So I can write this as big L just to be consistent. So we have a length, right? We're given length in the problem, and we have our voltage right here. We have a voltage. So we can find both of those. But for our drift velocity, we don't have this mu, okay? And that's not just equal to mu naught. Some people sometimes make that mistake there. So if we have conductivity, we have this equation for conductivity. We can use Q and N for our electron density to solve for mu value here, okay? So we can do sigma divided by this Q charge, so this is just an electron here, multiplied by the electron density, so electron multiplied by electron density, and then conductivity divided by the electron multiplied by the electron density. So that can solve for our mu here. So basically at this point, it's just sort of plug in what we got for part 1 into this, multiply by our E field, which is just voltage divided by length, and then we can solve for the drift velocity here. Okay, and then for power, essentially we are going to do V squared over R. Right up here, I put the general equation for R. So this, just kind of zooming in, we have our length, right, over our conductivity, okay? Conductivity represented by sigma, and then times S. And so our S is our uniform cross-section. So I drew this over here. So essentially our uniform cross-section, if we have a wire, is this, is just basically like a circle, right? Because we cut into that wire, we got our electrons moving in there. So for our uniform cross-section, it's going to be pi r squared for that surface area. And that's going to be pi times 2.5 millimeters squared. So we were given the diameter, so the diameter divided by 2, okay? So that's going to give us our uniform cross-section. So we use that to find our resistance. And once we have our resistance, we can go ahead and plug that into our equation here. So we have our resistance. 1 over R, we just sort of flipped the denominator here. So we have L, right, on the bottom, and then sigma S on the top, okay? Sorry, I changed the case here. Maybe I should just keep this as capital L just to be consistent. Okay, and then that's going to be multiplied by our V squared. So our voltage in this case is still, we have 50 volts. So we're given our voltage. So we're just plugging that in here, and then that will give us our total power in watts. Okay, so we have our electron drift velocity in meters per second, and then our power in watts. So this problem is not super complicated conceptually, but there is a lot here in terms of like electron density. What value is that, right? Conductivity, like where does that come from? You might be given resistivity. And that has a relationship to conductivity. So essentially, like, bring your textbook to the exam, because I would hate to have you stuck on a problem like this and not know how to find these variables, or what they are, because this is essentially like a word problem. So yeah, so hopefully that solution helps. I would also maybe look at a couple more examples from chapter 4 if you're not comfortable finding these values within the chapter.